Yeah, that's so. So what you learn when you study science in general, but astrophysics especially, that you no longer invoke your senses to judge what makes sense, or you no longer invoke your personal philosophies to judge what should be true. The universe is what it is, and it really doesn't care about your senses. Yeah.
Houston, we have a problem.
We copy going down. We got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
Are we spinning? Should be a short video, as the answer is clearly no, we are not. Alright, hope you guys enjoyed the video. This has been Jaronism. Till next time. No, okay. Maybe we need to go into a bit more detail here, but let's make sure that we all agree that no one has ever felt these ridiculous speeds. It is assumed and presupposed and taught to children as fact. Even though, has anyone ever felt the 1,000 miles per hour that we are said to be traveling at the equator? No. Has anyone ever felt the 66,000 miles per hour we are flying around the sun? No. How about the 480,000 miles per hour that we're traveling with the sun around the Milky Way galaxy? No. What about the 1.3 million miles per hour that we travel with the Milky Way galaxy around the Great Attractor? No. In fact, they could change it to 91.5 billion miles per hour, and would anyone feel a thing? No. And as crazy as those numbers even sound, we are told that the closest star to us is some 25 trillion miles away. No. These are just numbers and just math needed to show that we are in an ever-expanding, limitless universe, flying around at ridiculous speeds, but none of us has ever felt a thing. Now, before we get too deep, let me say, as I always do not trust me. To do your own research, this video is my opinion. I want to show some reasons why I think there is no way that we are spinning, but people are free to their own beliefs, and they need to make up their own minds. You are free to believe what you're taught. You're free to believe that you are spinning on a space rock in the vacuum of space around a sun that is just one of over 100 sextillion stars. You can believe that if you want. Or you're free to open your mind and to question what you're taught. The only problem is, if you question it, you face the criticism and the name calling. And so, opening one's mind comes with the labels, and then the shame, and it's all by design. While if you accept the religion of space, well, this gets you opportunities, and an easy way to fit in and to seem smart. It's gravity, you fool. You ever heard of Newton's laws of motion? So, even questioning whether you are spinning right now or whether you are flying about the universe at 1.3 million miles per hour comes with some backlash. However, I'm questioning it, so get over it. Now, we're about to talk a little bit about math, and so I hope people understand that despite what you might hear elsewhere, math is not reality. Math is a human creation, and while it may describe reality, it cannot prove it. Why? Well, because we invented it. If the foundations are wrong or the axioms are off, then it can appear to be reality, but it is nowhere close. Math is math, not science. Math is the culprit here. Things that are said to be true because we say so. Because Einstein wrote some equations that say that space-time can be bent, doesn't make it true that space-time even exists, let alone that it can be bent. It's math. The human conception that ignores experiment but instead builds its knowledge around agreed-upon equations. In a Vsauce video titled How to Count Past Infinity, Vsauce states, and I quote, "This is math, not science. The things we assume to be true in math are called axioms, and an axiom we come up with isn't more likely to be true if it better explains or predicts what we observe. Instead, it's true because we say it is." End quote. Ah, it's true because we say it is. Well, good thing we can never fall victim to being fooled through math. Oh wait, it's actually a perfect way to be fooled. He goes on to say, and I quote, "Its consequences just become what we observe. We are not fitting our theories to some physical universe whose behavior and underlying laws would be the same whether we were here or not. We are creating this universe ourselves." End quote. Yes, with just math, you can create whatever you want. A physicist has said before that one can create an equation that says an elephant can hang from a cliff holding on to a branch only, and while math may say this is possible, reality knows better. He then states quite plainly, and I quote again, "So to what extent we're inventing all this or discovering it is hard to say." End quote. Very hard to say. But one thing we can certainly not say is math is reality. Let's remember that as we cover some of this math. Okay, so are we spinning? First, whenever we're discussing this topic, many people will want to use angular speed. Why? Well, because the angular speed is the same no matter where you might be on Earth, while linear speed is simply distance over time. So we can make this simple with this simple circle animation. Consider first this circle is a merry-go-round with a circumference of 100 feet. Now clearly, to anyone who can just think at all, the blue dot, and we can pretend these are horses since this is a merry-go-round, the blue horse moves faster over a given time. The green horse moves the slowest because of the equation distance over time. The blue horse is going around 100 feet in, say, 4 seconds, but the green horse, which has a much smaller circumference, is going only 10 feet in that same 4 seconds. But if we use angular speed, well then both the green horse and the blue horse have the same angular speed, but very different linear speeds. The blue horse is going 25 feet per second, and the green horse is going 2.5 feet per second, 10 times less. This makes sense. Someone at the center of the merry-go-round will definitely feel a different speed than someone at the edge. However, if we use angular speed, as most globe proponents will want to do, then the speed of the horses is all the same. They're all moving the same angular speed. The blue horse on the outer edge and the green horse towards the middle. So it makes sense why they want to use radians and talk about angular velocity, because they would be the same. But we know someone at the outer edge of the merry-go-round would always move faster than someone near the middle. Here we have an article from Fizzlink.com that asks, if I'm on a merry-go-round with a friend and the friend is closer to the center than I am, are they going faster than I am? And the answer is no. You're going faster. The merry-go-round is rotating with uniform circular motion. That means that it rotates at a constant angular speed. They then go through a little bit of the math, which again shows that if you mean linear speed, then someone at the outer edge moves fastest. But since you're both circling with uniform circular motion, you are both moving the same angular speed. But again, the closer you are to the middle, the slower your linear speed is. The next little trick that globe believers use is to say, well, yes, we are spinning 1,000 miles per hour at the equator, but we're only going around once per day. No one could ever feel that. Well, in a sense, they're most certainly correct. On our merry-go-round here, if the blue dot moved around at, say, 1 rotation per day, you wouldn't even know it was moving. It would be so slow. But here's the trick. Remember, this merry-go-round is only 100 feet in circumference. So let's extend that to, say, a mile. So now the merry-go-round goes around 1 mile per day. Now, would the blue horse know that it was moving? Well, just barely. Not quite like grass growing, but if you looked out, you would be able to tell that you were moving. But it would be very, very slow. You'd be moving at about 1/25th of a mile per hour. But to see if we'd notice flying 1,000 miles per hour at the equator, we'd have to take that small speed we were just talking about, that 1 mile per day, and multiply it by 25,000. Think of anything moving at any noticeable speed, and then think times 25,000. It's ridiculous. Think of seeing a car drive by at 30 miles per hour. Okay, well, 25,000 times that is 750,000 miles per hour. Ridiculous. So think of a car going 1 mile per hour. Now times 25,000, that's 25,000 miles per hour. So I hope you can see how insane it is to multiply any speed by 25,000. But that's what we need to do to compare it to the speed that we're moving on the Earth. That merry-go-round at 1 rotation per day, which is 1 mile per day, needs to be multiplied by 25,000. The speed would send anyone flying off the Earth without a doubt. Let's get back to our example and how it compares to Earth. But my hope is that you realize why I think angular velocity is just not needed here and why globe believers will jump to use it. They want to use angular speed because they want to say that both the blue dot or the gray dot, the red dot, and even the green dot are all going the same speed. Angular speed lets them do that. Linear speed does not. So linear speed says that the horse on the outside has the greatest linear speed because obviously it has a greater radius. And angular speed says the speed of all the horses is the same because they all make 1 revolution in the same time. Okay, moving on to a globe Earth, since we know linear speed is simply distance over time, we can easily figure out the linear speed for any location on a globe Earth. The circumference of their latitude, which would be d, over time of rotation 24 hours, which would be t. So, at the equator, we have a circumference of 24,901 miles. We divide that by 24, and we get its linear speed of 1,037 miles per hour. For Los Angeles, we get a circumference at that latitude of 20,670 miles. Divide that by 24, and we get a linear speed of 861 miles per hour. For Anchorage, Alaska, a circumference at that latitude is 12,000 miles. Divide by 24, and we get 500 miles per hour. Move to the tip of Greenland, circumference of 2,771 miles. Divide that by 24, we get 115 miles per hour. And at just outside the North Pole, a circumference of 86 miles. Divide that by 24, and we get about 3.5 miles per hour. And again, with linear speed, this is very easy, right? The equator, 24,901 divided by 24 is 1037. Alaska, 12,000 miles circumference, 24 hours equals 500 miles per hour. Very easy. But now let's look at angular speed. So the equation for angular speed is velocity equals the angular speed times the radius. So 1037 miles per hour equals the angular speed times the radius, 3959. So the angular speed equals 0.26 radians per hour. So now let's look at the angular speed of Alaska. Again, V equals WR, so that's 500 miles per hour equals W times the radius of 1910. So W equals 0.26 radians per hour. So now you can see that the math is what allows it. The equation for angular speed, no matter where you choose on Earth, is always 0.26 radians per hour. And if you see here, if you go to this site, this little conversion tool, and put in 0.26 radians per hour, what does that equal? Well, it equals 0.999 rotations or revolutions per day. So now you can see how they always want to discuss this topic with angular speed, because linear speed exposes the nonsense. Because angular speed says that all horses anywhere on a merry-go-round are all moving the same speed. And get this, that's no matter how big the merry-go-round is. That's crazy talk. Think if a merry-go-round was 1 million miles in circumference. To think that all the horses on the merry-go-round would move at equal speed is kind of loony. Imagine being on an inner horse, then be taken to an outer horse near the edge. Wow. And so, they want us to think that no matter where you are on a merry-go-round, it would always feel the same. That's truly insanity. The difference in speed would be clearly measurable, and yet it's not. It's all mathematics again. We already heard Vsauce tell us that math is not science because we invented it. In math, we decide what's true. Numbers are not even things. They aren't concrete. They are not even nouns. They are adjectives that describe things, no different than colors, really. You cannot show me green any more than you can show me 5. You can show me a green car, green being the adjective there, and you can show me 5 apples, which is just an adjective and a way of describing a set of apples. But math is just a human invention, and much like the elephant earlier, math can be manipulated in so many ways to show us something is true. Because, well, we say it is. Here's a quote by Nikola Tesla talking about the reality of mathematical equations. He said, and I quote, "The scientists from Franklin to Morse were clear thinkers and did not produce erroneous theories. The scientists of today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quite insane. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality." Nikola Tesla. That was from his Radio Power Will Revolutionize the World, July 1934 article in Modern Mechanics and Inventions. We can simply look at centrifugal versus centripetal force to see another glaring example, and we can find more of the quote-unquote tricks of the trade. Centrifugal force is the moving or tending to move away from the center, versus centripetal force, which is the moving or tending to move towards a center. If you forget which is which, like I did for a while, an easy way to remember is to think of the F and the P. When I see the F, I think of flying off or flying away, and when I see the P, I think of pulling towards the center. So maybe that will help you a little as well. Now watch the trick here. The formula for centrifugal force is the centrifugal force equals the mass times the velocity squared over the radius. And the answer is in newtons. And the formula for the centripetal force is force equals mass times the velocity squared over the radius. And the answer is in newtons. Wait, aren't they the same? One for the force flying out and away, and then the other is the force pulling inward? Then you might see that in the general theory of relativity, that it just so happens that gravity and the centrifugal force are equivalent. In order for something to stay still while on a spinning platform like a merry-go-round, they say that all the forces need to add up to a zero vector. Well, to do that, you need the fly-away force to equal the pulling-in force. So when you include our weight, which they say is because of gravity, then you can start to see the mathematical tricks involved. Your senses go right out the window. Really, Jaron, doesn't science require our sense of observation and depend on our senses? Nope, not even close. Let's let Neil deGrasse Tyson tell us so we are all clear here about science and our senses.
Yeah, that's so what you learn when you study science in general, but astrophysics especially, that you no longer invoke your senses to judge what makes sense. Or you no longer invoke your personal philosophies to judge what should be true. The universe is what it is, and it really doesn't care about your senses. Yeah.
Oh,